Hello guys, this is my second YouTube video and we're going to teach you why the hell indexes on list and arrays start from 0. So in this video I'm going to use C++, but don't worry, this video doesn't require any programming dependencies. I'm going to teach you anyway. So let's hop right in. It's going to be really easy and fun ride. So I'm going to open my MS Paint. I made something ready for you. So let us suppose that this is a RAM block, right? So the place where our data gets stored individually. So each of this block stores a 1 or a 0 that is 1 bit. Okay, so let's suppose that. So in C++, okay, so one integer takes 4 bytes, that is 32 bits of memory. So you know 1 byte is 8 bits, right? So I'm gonna, okay, there's a grammatical mistake. So I'm gonna write something like so I'm gonna create an integer a which stores 9, okay, let's say 90. So whenever we assign a variable a that stores 90 and it is said to be an integer, it automatically allocates. Okay, so by allocates I mean it's not going to take more space than that, it's not going to take less space than that. Okay, so it's going to take exactly 32 bits of memory as assigned. Okay, so in C++ it's uh, extremely strict. Okay, so when I say a is 90, so it's going to convert that 90 into binary form and it's going to take 32 bits of memory. So what I mean by 32 bits is 32 of these blocks horizontally. So whenever we store any variable and give it a value, so it always has an address so that we can access the value anytime during the program. Okay, so we need to access it, right? So generally the access address is in hexadecimal, so you may see something like 0x987 whatever, this long string of numbers. All right, it's not random, it has a meaning, that is addressing of this variable. So let us suppose that this variable begins from here, so it has an address something like I'll assign it hexadecimal. Okay, so 0077 a, it's a b, so it's completely random. Okay, I'm not using it anyway. So this is, let's suppose that this is what is getting stored. Okay, so this address is hexadecimal position. So what this hexadecimal position means? So you may ask what this hexadecimal number means in the locationing address. So it is something like from the beginning of this RAM, so there may be other blocks before it, so to this position how many, so you may convert this hexadecimal into bytes or bits, whatever. So if you convert this into bits, so it means directly it is this much bits after, okay, this place, this block, the initial of this a, okay, so where it is stored is this much bits or bytes after all the rams before. Okay, so this is what this hexadecimal position means. Okay, so whenever we store this integer into a, it takes something like a 32 bits of block. Okay, so 32 blocks, I have not counted to the point. Okay, there are some 32 blocks of memory it gets stored in, so it's completely random, not random, but okay, so it's zeros and ones and zeros. All right, all these random numbers. So after this beginning initialization happens, whenever we access, it's just going to do this: find the address, get access of the variable, and what is stored in it. Checks first of all the integer size. Okay, the size is 32 bits, so it's going to take all those 32 bits and calculate whatever is stored in it and show it to us. So after that, let me teach you concept of array, right? So array is something as specialized integers. Okay, let me suppose that. So I'm creating an array which has 4 integers, because what are those 4 integers? 1, 2, 3, and 4. I'm not creating 4, I'm just creating 44. Okay, I don't care. So whatever is stored inside. Okay, so this one is going to take 32 bits of space, no matter how small it is. Okay, it's going to take 32 bits of space. So you get what I mean, right? So this, since this one gets 32 bits of space, because each of these are what I've declared as integers, right? So this array, new array, has 4 integers, which are this. So each of these are going to take 4 integer space. So what is one integer space? One integer space is 4 bytes or 32 bits. So each of these is going to take 32 bits. So with a quick calculation, we can find out that 32 times 4 is equivalent to 128 bits. I had pre-calculated it. I'm not talent. Okay, so 122 bits of memory is taken by this array. So whenever this array needs to be accessed, okay, so where value needs to be accessed out of this array, what we do is, as you may have guessed, the compiler automatically does something clever. So let's say this is a new array. So I want to access the first term. Why do we use 0? Wait for a second, I'll tell you. So whenever you do this new array 0, the compiler does something like this, right? This, whatever I've written here. So it's going to first find out the start of this address. Okay, so let's say that this array also starts from here. Okay, let's say that this integer is not there. So this array starts from this location. So what it's going to do is find start of the address. So what's the start of the address of new array? This, right? So after this finds in the start of the array, it adds an index, whatever that we pass here. Okay, so it's going to be 0, right? And times space. What is the space of each of these integers? It's going to be 32, right? 32. So it's 4. Generally, I'm not saying 32 bits, right? It's 4 bytes. Okay, so 4 bytes of memory. So it's going to take something like, okay, I'm going to show you visually, you're going to understand it more better. So it's going to be 0 7, so 0 0 7 7 AB 40 plus index, which is at first in this 0, when we want to access the first term, 0 times whatever the space is, 4, right? So it's space. It's a big, why is this 4? Because it's an integer, right? I have told you many times. So 0 times 4 is 0. So what we're getting is for the first term, right? So first term address is this. So as you've guessed, so when we do new array 1, so it's going to be a little comma. So 1, what's going to happen is, as you can guess, it's going to go 0 0 7 7 AB 40 plus 0 times, 1 times 4. So what this means is it's going to calculate how many bytes at start. So this is 1 times 4. So what's going to be calculated is this hexadecimal number is going to be converted first into bytes, right? Bytes. So it's going to be converted into bytes. And after we convert that into bytes, we add this because this 4 is in bytes, right? So it's going to get that location. So it's going to be start of the location, first a byte. So you get what I mean? So it goes first to the start of the location, then goes 1 byte. And after that, whatever there is accessed accordingly. So whenever we do new array 2, it's going to be 2 times that. So it's going to start the array, go first, then go to second 32 bits, and after that whatever there is going to be accessed. So whatever there, it's going to be 3, and after, when the new array is 3, the 44 is going to be accessed. So if you have understood my video, you can live peacefully now without worrying much about zero indexing. Thank you very much.